Chapter N is all about solving absolute value equations. And the technique for doing this is one that I believe we've gone over, but I'm going to go over again. I'm going to demonstrate it in a couple of simple examples and then move on to slightly more difficult ones. The idea here is that, as described in the introduction, an absolute value function is really a piecewise function. So that there are actually, for every absolute value that occurs in an equation, there are actually two equations that we need to consider solving. But what's important also is that both equations must be solved, and once again we will come up with potential candidate answers, but whether the answers we get are actually true solutions, we won't know until we plug them back into the original equation. So let's start with number 1. Absolute value of x minus 1 is equal to 3 can be broken up into two possible equivalent equations. If x minus 1 is actually a positive number, then we can dispose of the absolute value sign and we can just simply solve the equation x minus 1 equals 3. When we do that, we get x equals 4, and as can be readily verified, that is a true solution. Let's take a look at the other possible solution for x minus 1, absolute value equals 3. If x minus 1 turns out to be a negative expression, then it will be true that negative x minus 1 is going to be equal to 3, because taking the negative of a negative gives you the positive. So this may also be a solution as well. Let's solve this. Distributing the minus sign, we get minus x plus 1 equals 3, or negative x equals 2, or x equals negative 2. Let's go ahead and plug negative 2 back in. Negative 2 minus 1 is negative 3, and the absolute value of negative 3 is positive 3. So in this case, both of these possible solutions are actually proven solutions. That is the general strategy. You need to solve the equation assuming that what's inside the absolute value sign might be positive or might actually be negative, and you solve an equation assuming it's positive, and then assuming it's negative, you put a negative sign in front of it to turn it back into being a positive, which is what the absolute value function does. So let's see if we can go ahead and solve another equation that's pretty simple. Absolute value of 3x plus 2 equals 9. Again, we're going to split this into two possible equations. Again, if 3x plus 2 is actually a positive value, we could just take it outside of the absolute value sign and solve this. Getting 3x equals 7, x equals 7 thirds. Well, if we plug 7 thirds back in here, we get 7 thirds times 3 is 7, plus 2 is 9, and the absolute value of 9 is 9. Let's solve it the other way. Let's put a negative in front of the 3x plus 2 equaling to 9, assuming that, well, maybe 3x plus 2 is actually a negative value, which then becomes positive because of the absolute value signs. In that case, this equation ought to be true. So let's go ahead and distribute the negative sign. Negative 3x minus 2 equals 9. Add 2 to both sides gives us negative 3x equals 11, or x equals negative 11 thirds. Well, let's plug back negative 11 thirds into this equation. Negative 11 thirds times 3 is negative 11. Negative 11 plus 2 is negative 9. The absolute value of negative 9 is positive 9. So therefore, we have an equality, and both of these values are true solutions of the absolute value equality.